So yes, in previous slides we saw what is the definition of cloud computing. We also had some brief introduction about the cloud computing, and we also saw what is the vision of cloud computing, and we also discussed basic vision and also the apt definition for cloud computing. Now let us see the historical developments of cloud computing. So here you can see a pictorial representation of historical development, how the cloud computing technologies was evolved in the series of years. According, you can have the x-axis and y-axis, where they discuss about the cloud grids, clusters, and mainframe, and also you have when was the first mainframe was introduced and what is the web 2.0. It means that you also have the Microsoft Azure, Google App Engine, Aneka. So you have many other grid computing which was there, or you can just see in the pictorial representation of how the technologies are represented over the year. So yes, we'll see the historical developments. In tracking the historical evolution, we briefly review five core technologies that played an important role in realization of cloud computing. These technologies are listed below. That is, the first one is distributed system, the second one is virtualization, the third is Web 2.0, fourth one is service orientation, and fifth one is utility computing. So one by one we will see what it is. So when it comes to the distributed system, clouds are essentially large distributed computing facilities that make available their services to third parties on demand as a service. We consider the characterization of the distributed system. So, before going to this, I have one major thing to tell you guys. So, when it comes to the distributed system, we should know what it is, and we have to learn what the distributed system is trying to tell us. So, when it comes to distributed system, network of interconnected computers or node which will work together to provide shared resources or services. So when it comes to this distributed system, you have again three types in it, that is mainframe, cluster, and grid, that I'll be explaining in the upcoming slides. When it comes to a distributed system, you should always know that it is a collection of independent computers that appears to its users as a single coherent system. So you can also put it in other words by telling it as network of interconnected computers or nodes which will work together to provide shared resources as a service. So what kind of services that are, or what kind of types that are, that we will see in the upcoming slides. Now, what is the main purpose of the distributed system is, the main purpose of the distributed system is to share resources and utilize them better in the means of heterogeneity, openness, scalability, transparency, concurrency, continuous availability, and independent failures. So, as I told in the starting of the explanation, the distributed system has the what do you say, the types in it. So mainly you should know the three major milestones that have led to cloud computing in distributed system, that is mainframe computing, cluster computing, and grid computing. So we'll see each one of them one by one. When it comes to mainframe computing, there is there these were the first example of large computational facilities leveraging multiple processing units. Mainframes were powerful, highly reliable computers specialized for large data movement and massive input and output operation, mostly used by large organization for bulk data processing, tasks such as online transaction, enterprise resource planning, and other operations involving the processing of significant amounts of data. Highly reliable computers that were always on and capable of tolerating failures transparently. No system shutdown was required to replace failed components, and the system could work without interruption. And before going to the cluster point, I would like to add some more points in the mainframe computing. So, in the mainframe computing, you can also put it in other words by telling that mainframe, it means that main and frame. Try to understand these words. When it comes to mainframe, the large computers are there and it has large data to process. So large scale computers used by organization for bulk data processing. So what kind of the bulk data processing will happen here is high processing power, larger capacity, higher speed, that is input output operation, advanced security operation, and support multiple OS. And if you want me to tell the real world examples, that would be IBM Cloud, AWS mainframe, and Google cloud of mainframe. Next, let us see the cluster computing. So, when it comes to cluster computing, started as a low cost alternative to use the mainframes and supercomputers. These machines could then be connected by high bandwidth network and controlled by specific software tools that manage them as a single system. Built by commodity machine, they were cheaper than mainframes and made high performance computing available to a large number of groups, including universities and a small research lab. Some frameworks for distributed computing, including Condor Parallel Virtual Machine, that is PVM, and Message Passing Interface MPI. So again here, before going into the next point, if you want me to add some points to cloud computing, that in that we were talking about the historical developments and the types of that, you have to always make sure you keep the terms in simple. So when it comes to the cluster computing, it is so simple that you can say in this form: multiple computer or nodes connected together to form a cluster. So here they try to work together to achieve a common goal. The main reason to use this cluster cloud computing, it's only because it is the low cost alternative for the mainframe. It has high speed network connectivity, and if you want me to tell about the application, it is used in the scientific research, data analytics, and weather forecasting, and etc. Now, what is the difference between the main computing, that is mainframe computing, and cluster computing? If you are asking me that, then mainframe had a centralized computing system, where cluster has connecting multiple system together as one. So this is the major difference between the mainframe and the cluster. Now, when it comes to grid computing proposed a new approach to access large computational power, huge storage facilities, and varieties of services. Users can consume resources in the same way as they use other utilities such as power, gas, and water. A computing grid was a dynamic aggregation of the heterogeneous computing nodes, and its scale was nationwide or even worldwide. Why computing grids is cluster become quite common resources. They were often underutilized. New problems were requiring computational power that went beyond the capability of single cluster. The improvements in networking and diffusion of the internet made possible long distance and hybrid connectivity. Basically, if you want me to tell about grid computing, it is the computing infrastructure that combines computer resources spreaded over different geographical location to achieve common goal. New approach that access large scale computational power, and it has a huge storage, we can say. So next is the virtualization. So we all know what is virtualization. Virtualization is something which run on a physical host which shares the resources and virtual software. It has a virtual VMware, and you can use this virtual machine where it is a creation of virtual version of something such as operating system, server, storage devices, and network resources. It is the process of converting a physical IT resource into virtual IT resource. It is encompasses of a collection of solution allowing the abstraction of some of the medical elements for computing such as hardware runtime, storages and networking. Virtualization is essential technology that allows creation for different computing environments. These environments are called virtually because they simulate the interface that is expected by the guest. Hardware virtualization is a technology allowing simulation, evaluation, the hardware interface expected by an OS. Hardware virtualization allows the coexistence of a different software stack of stack stacks are contained inside virtual machine instances which operate in a complete isolation from each other. High performances of servers can host several virtual machine instances, thus creating the opportunity to have a customized software stack on demand. This is the base technology that enables cloud computing solution to deliver virtual servers on demand, such as Amazon EC2, RightScale, VMware, vCloud, and other together with hardware virtualization, storage, network, and virtualization. Virtualization technologies are used to replicate runtime environments for program. Application in the case of process virtual machine, instead of being executed, the OS are run a specific program called as virtual machine. Process virtual machine offer a high level abstraction with respect to hardware virtualization, since the guest is only constituted by an application rather than a complete software stack. For example, Google App Engine and Windows Azure. So in upcoming slides, we'll see what is Web 2.0 service oriented and utility computing.